Today's video will demonstrate how to optimize a multi-way if statement. Hello, I'm James Helfrich. One of the most common things we do in programming is write if statements. And an if statement is multi-way when there's more than two possible outcomes. This video will demonstrate several techniques we can use to optimize multi-way if statements. Many decision structures in code are not binary, instead containing three or more options. The most common way to represent these is with an if-else structure. So if I have a flow chart that has 1, 2, 3 decisions, and there's me 4 possible actions I can take. This is an example of a few option decision tree. Now, there's a couple different optimizations we can make. The first and most common is to avoid redundant Boolean expressions. The second is to put the most common case first and the least common last. The next is to nest if statements whenever possible. And, of course, avoid empty bodies. Let's take a look at the first, avoid redundancy. Consider the following pseudocode. If grade is greater than or equal to 90, then a letter is an A. If the grade is between 80 and 90, then a letter is a B, and so on. Now notice that the grade is less than 90 is redundant because we already know the grade is less than 90 because we were the else part of the previous if statement. So therefore, we can optimize this by removing the redundant expression. The next optimization is to put the most likely case first. We can only do this when we have data as to the likelihood of a given option. That being said, an educated guess is really better than no guess at all. So for an example, let's say I say grade is less than 60%, then it's an F. If it's less than 63%, there's a D minus. It's less than 67%, it's a D, and so on. Now, it turns out that Ds and Fs are rather uncommon. The most common grades are As and Bs and Cs. So therefore, I can reorder this by saying, if grade is greater than 93, an A, else if grade is greater than 90, then A minus, and so on. For performance reasons, we should nest if statements whenever possible. Know that this will cut execution time for a large number of options from O sub n to log n. However, it might decrease the readability of code. So for an example, let's say I want to assign a letter grade from a number grade. Well, I can say if, else if, else if, else if, else if, else if, else if. Now, an optimization would be say, hey, if grade is greater than 80, if grade is greater than 90, if grade is greater than 93. Using this scenario, the typical case will only have 3 if statements, whereas the other example, the typical case will have 10 if statements. The final optimization is to avoid empty bodies. Almost always when we have an empty body, this programmer is careless about the implementation. For an example, if I want to append a plus or minus onto the end of a number grade, then I will say, hey, if the grade mod 10 is greater than or equal to 7, in other words, it ends with 7, 8, or 9, then add a plus. If it's greater than or equal to 3, then do nothing. Otherwise, append a minus. An optimization would be to remove this pass by simply saying, if grade mod 10 is greater than or equal to 7, then append a plus. Otherwise, if it's less than 3, then append a minus. Here's an example. Take a look at the following code in JavaScript. I want to determine if a given year is a leap year, and I have 4 options: the quad century, the quad year, and the odd year. Now, the first thing I'm going to do is notice the redundant Boolean expressions. If year mod 400 equals 0, then I'm going to return true, so there's no way I'm going to get to the second part of that. So I'm going to remove those immediately. The code is a lot easier to understand as well as has less execution time. The next thing I'm going to do is I'm going to reorder these for the most likely case first and the less likely case last. Currently, I have a 0.25% chance of being on a quad century, yet it's the first one. And I have a 75% chance of being the odd year, which is the last one. So if I reverse the order, then I'm going to have the most common case, 75% of the time, is going to do the quad year check once. The next most common, which is something that is evenly divisible by 4, but it's not a century, is going to be the other 95%. So therefore, I'll only hit the last case 1% of the time. This is example 7.2 in the few options section of the decision chapter of the software design textbook.